Hi, I'm Dr. David Dobson. Welcome to Conversations. Today, my guest is Mithila Shivkumar, who is currently pursuing her PhD in computer science at the University of Ottawa. Today, we will discuss her master's thesis from York University, which explored how large language models like GPT-4 can help automate safety case generation. It's a pleasure to have you on my show, Mithila.
Hello, Dr. Robson. Thank you so much, and thank you for inviting me to your interesting conversation show.
Mithila, let's start with your journey. What sparked your interest in computer science and how it led to your current research on using generative AI and safety cases?
Thank you for the question. Actually, it's a very interesting story because, like, back in high school, we had back home in India, I had an option to choose elective, and I actually chose like biology, which is towards medicine. and and I when I completed my high school, the trend was IT at that time, and everybody in my class like chose that. And I thought maybe like that would be a very interesting field, and that's how I accidentally came in IT field. But and I also chose information technology as my major because it is a combination of both computer science and a touch of electrical engineering course, so I'll get a taste of both. And I think towards the end of my bachelor's, I was determined that computer science is my way of path. So, and that's how it led to my master's. So, when I started my master's at York University, my supervisor at that time, Dr. Alvine Bell, so she had a couple of projects, and she mentioned this topic about safety cases, and again at that time, LLMs or large language models were booming, and we thought we'll do something at the intersection of that. And I was completely new to the topic. I had heard of safety assurance, but I've never worked on safety cases. So I took it as a challenge, and this was a very interesting topic. And that's how, like, at the intersection of LLMs and safety cases and safety assurance, that's how it all came together.
Wonderful. Uh, I want to ask you, what is a safety case and why does it matter?
Yeah, thank you. Like most people, even I didn't know what a safety case is before I started my master. So basically, to explain it in like very simple terms, I would say safety case is like it's like an argument. Like basically, it is a part of it's a type of something called as an assurance case, which is used in safety assurance. So basically, there are different types of assurance cases. One covers safety, one covers security, and so on. So this assurance case, you can see it as like an argument, and it has like different types of arguments which is supported by evidence to show that one particular objective is achieved. So every safety case has a main objective, which is because it's a safety case, it's like a given system is safe, or this algorithm is safe, which argues, like for example, an algorithm which avoids collision, it actually does what it says. So that will be the top objective, and you will have a set of arguments and evidences to show that actually that objective is achieved. So basically, the technical definition would be it's like an argument which has an evidence to show that a system is acceptably safe to operate in an environment. And it is actually mandated by many standards. Like there is a standard called ISO 26262, which is a standard in the automotive domain, and that standard mandates that for every automobile created, the safety case has to be created. And this safety case is sometimes it spans like 1,000 pages. It's a very large document, and
Mhm.
it is like manually created and obviously error prone, but it's a very large document, something like a flow chart kind of
Okay.
representation. There is textual representation as well, but in industry, like there's something called as GSN, called goal structuring notation. It's similar to a flow chart. It has like rectangles and circles.
Okay.
So it doesn't only comprise of that. That is one part of a safety case. There are also other documents, like evidences run from different tests. All together, it comprises a safety case.
Okay. Uh, how can you already mentioned large language models? So how can LMs, specifically OpenAI's GPT-4, be leveraged to automate the generation of safety cases for cyber physical systems?
Sure. Yeah. So basically, when I started off with the literature review, reading about literature about safety cases, and what I found was one particular issue was that automation was a very hard topic in terms of safety case because it's like very long. It was manually created, and very less amount of work was done in terms of automation. And to my knowledge, and none of the existing work, they utilized a large language model. It was like some other methodologies to automate a part, that too you can automate only a part of the safety case, right? So, and me and my supervisor, we thought it is timely that now that large language models are booming and OpenAI came up with different models, why can't we experiment with it and see if it can actually understand what a safety case is, if it can understand what a goal structuring notation is, and if it can actually generate something like not hallucinate and generate something valuable as
Mm,
part of a safety
mm,
case.
okay,
And yeah.
nice. Mithila, your research found that AI could produce moderately reasonable arguments. Can you elaborate on the effectiveness of GPT-4 in generating structurally correct and reasonably safe cases based on GSN standard?
Sure. So we started off this research, and uh, our research, it had like two different parts. So the first part, we actually wanted to know if GPT understands what a goal structuring notation is, which is like the
Mm,
widely used representation of safety cases. So we formulated some 19 questions and prompted GPT for those questions. Like, for example, the questions will be like, do you know what is GSN? Like, GSN stands for, sometimes like in the results, if you see, one run of the experiment, GPT would say it's goal structuring notation, and for
mm,
some other run, it will say something unrelated to goal structuring notation. So we wanted to see if it understands what GSN is. And GSN has many rules, like this has to be in a rectangle, and this
mm,
particular component has to be in a circle. So it has set of semantic and syntactic rules. And there is a GSN version 2.0, I think. That's a standard, like a book, which
okay.
lists all these. So we assume, like, since the models like GPT-4, they are like trained from different sources all over the internet. So we wanted to
Mm,
check if it is actually trained on this as well. So it like, to our surprise, we did multiple experiments. We prompted for different runs, and when we took an average, we took it something like a marking system, and
mm,
GPT actually passed with the grade of A, like
mm,
similar to what you find when you check it with the university ranking. So it was pretty good. It understood GSN pretty well, and we did not give any information about GSN to GPT-4. And this was the first part. And in the second part is when we actually utilize GPT-4 to generate a part of a safety case to see if it can generate something useful. And we chose like a couple of existing safety cases from literature, and we gathered information from that, and we did multiple experiments. Like, one experiment, we did not give any information about the system, just the name. And
mm,
another experiment, it will be like we gave all the evidences, all the information from the safety case. And
mm,
it actually generated like pretty, as you mentioned, like moderately reasonable arguments.
mm,
But the problem was, like, when it comes to domains like safety and security, even like an accuracy of 50, 60, or even 80% is not good. You need like
mm.
99.9 something, because it concerns like life sometimes. So for example, we cannot let
Yeah.
out an autonomous vehicle,
Mm.
like the robo taxi or something, if we know that this accuracy only 50%.
That's true.
Yeah, yeah. So that's when we concluded that at this point, at least, a large language model like GPT-4, it
Mm,
can act as an assistant maybe to a
mm,
safety case developer, because safety cases are, as I mentioned, are very large and they are manually created. Maybe it can act as a starting point, and the human can interfere in that and say, okay, this is this, I will change this, because humans have the critical thinking ability.
yeah.
And yeah, that's how we achieve the results.
Mithila, your research found that while GPT-4 can generate safety cases with high semantic similarity, its structural correctness and reasonably were only 50% accurate. How do you think we could improve the structural accuracy and reasonability of AI-generated safety cases?
Uh, yeah, thank you for the question. So, when it comes to semantic similarity, I think use the cosine similarity function from Python, and it basically measures the meaning behind two sentences.
Mm,
So, I would like to say something about safety cases here. So, no two safety cases can be same. So, I
mm,
can create a safety case for a system, and you can create a safety case for the same system,
okay.
but it might look completely different. It will have
Mm,
different evidences, different number of evidences, different number
mm,
of goals. But the meaning behind or the main objective behind those two safety cases will be the same. So
okay.
that's why we decided to measure the semantic similarity. And we got around 80%, which was like really good. GPT-4
Mm,
actually created something reasonable,
mm,
similar to a ground truth safety case.
mm,
But when it comes to the structural, which is like the goals and strategies and evidences as part of a safety case, it I wouldn't say it performed like really well or really bad. It's like in the middle.
mm,
And I think at that time with that particular model, we were able to get these results.
mm,
Maybe with more experimentation, like there are different techniques of prompt engineering coming up every day, and every day
mm.
there is a new model coming out.
Yeah,
So
true.
yeah,
Yeah,
maybe now if you run the experiments, it will do much better. I'm not sure. So I think like exploring more prompting strategies like chain of thought or like
yeah,
using zero shot, one shot, and
yeah.
like with a mix of combination of both, it might lead better results.
Mithila, considering your findings that GPT-4 is able to generate moderately accurate and reasonable safety arguments, where do you think the line should be drawn between using AI to assist in safety case generation and relying on human expertise?
That's a very interesting question. Like, and I think like even in literature or in recent times, this has been like
Mm,
spoken about really
mm,
by a lot of people because like finding the right balance
yeah.
in human and AI.
Mm,
I think a lot of research is going on and currently
mm,
even in that like it's very important to find that right balance because I think it changes for different systems and especially when it comes to domains like safety. um, I think right now at this point human intervention is a must, uh,
mm,
and that's what we understood from doing those experiments.
mm,
Because when it comes to like safety again it involves like fatal accidents or incidents, we
mm,
need to prevent them, and
mm,
just leaving that in the hands of AI,
mm,
I don't think that would be reasonable. At the same
mm,
time, just humans, they might be like
mm,
overworked or overwhelmed by the
mm,
number of pages or how long it is. So I think it is maybe research on something like what tasks to assign to AI and
mm,
what tasks to assign to human, because there
mm,
might be some tasks which humans take 5 days to do and AI can do it in seconds, and there might be some tasks which AI don't do properly. For example, with respect to some regulations, data regulations, AI has some limitations. So
mm.
I think it is imperative to do some analysis on this part and see like what to apply to each AI and humans.
Uh, Mithila, given the rise of large language models, LLMs, in various software engineering tasks, what do you see the most significant ethical or safety challenges we need to address as these models become more integrated into the development of critical systems, such as the lane management system mentioned in your research?
Yes. So, as I mentioned in the answer to my previous question, I think like there are certain limitations with regards to AI. For example, in recent days or recent years, you can see like the data privacy and the ethical concerns which are arising as AI becomes increasingly incorporated. For example, we have like General Motors sending out like robo taxis and Tesla and even Waymo working on those. And I've seen some cases where like I have even like seen some where the glasses for the Meta, they
Mm,
scan like random people faces and they can list the names. So
mm,
it's obviously a privacy concern, and I think like we need to incorporate this in the requirements engineering phase. Like basically, when in requirements engineering, when we're devising requirements, there should be certain thing for privacy requirements, and we need to make sure that, for example, in Canada, the PIPEDA or GDPR in the European Union. So we make sure that this implementation has to comply with the laws and regulations from those bodies, to make sure like the individuals have right to their data and AI doesn't interfere in that.
mm,
I think it should start from the scratch, like from the beginning, before even the implementation,
mm.
which would be really helpful.
Mithila, given the current research on automatic generation of safety cases, what are the most significant challenges that remain in creating a fully automated, comprehensive, and reliable system?
Huh. I think like there are many challenges right now. But um, back at that time during my thesis, I think like fully, completely automating a safety case will not be possible, because
Mm,
as I mentioned, safety case has,
mm,
it's not just the
mm,
diagram or the
mm,
flow chart. It has a lot of other documents and
mm,
artifacts,
mm,
evidences like field test results,
mm,
integration test results, and a lot of stuff. And while humans can go about it, or right now, like I see a lot of papers and literature talking about how AI can help in doing requirement engineering tasks or
mm,
assist the humans in automating certain tasks. So maybe I think at this point in 2025, it cannot be completely like fully automated. Maybe like
mm,
we can choose the paths which are like very difficult or which takes a
mm,
long time and it's error prone, and use that.
mm.
uh, who knows, in the future everything will be automated at that point. It might be possible, but now
What is next for you, Mithila?
Well, I'm currently, I just started my PhD at the University of Ottawa. I might not completely follow what I did in my master's thesis, but
Mm,
something on the lines of large language models and requirement engineering from software engineering,
mm,
intersection of those. I'm trying to come up with the research topic with my supervisor, and
mm.
yeah, the next 4 years I'm going to spend doing my PhD thesis. So that's, as of now, that's on my mind. So
Thank you for sharing your research, Mithila. All the best with finishing your PhD.
thank you so much, Dr. Dobson. Thank you.